Okay, short 30-minute stream. I'm trying to get more consistent at this so that I don't get washed. Let's go.
Alright, so let's continue this problem. We're talking about how to find tangents to curves at certain points, which in and of itself is a very interesting question. Specifically here, we're trying to find the tangent line to this curve at that specific point. And I've walked you through this already. What we're trying to do is fill out the difference quotient, which you guys are familiar with, and then take a limit as h approaches 0. In other words, letting one point get really close to this point. Therefore, we have a tangent line to that curve at that point. So we're almost there. We have our f of 3 plus h, we have our f of 3, and we're trying to find out, as h approaches 0, what this thing's going to be. That's what we dealt with last time. You remember inventing that last time, I hope, yes? Mm-hmm. Okay. So we already have this part. We already have this part. Let's make our substitution, and then let's see what we can do with it. So if we have this, we'll have our limit as h approaches 0. Notice you have to keep writing your limit until your limit is gone. It's a must. Instead of f of 3 plus h, please tell me quickly.
Crap, I forgot where that came from. Got to go back.
This means
rise over run. Is that where that comes from?
1 plus h. 0 plus h minus f of x sub 0 all over h.
Crap, dude.
Yeah, it's hard to say, isn't it? F of x, that's why you get a master's degree, you can say all this. They teach you all, no, that's not what they teach you. F of x sub 0 plus h, sure, minus f of x plus 0, f of x sub 0. So this right here is our delta y. This right here is our delta x. So right now, so this is our point, variable. What was the other point that I used? Q. Yeah.
Okay, yes, point PQ. P is at x sub 0, Q is at x sub 0 plus h.
Well, we need how many points to make a line? 0. So
rise over run.
Write that out. Don't do the math in your head, just because you're making a mistake on that right now, some of you. I want you to write out exactly what it is. Write out exactly what I want you to do. What is it? F of x sub 0.
Change in y over change in x. The change in y is, well, the change in x is h. The change in y is
plus h. That's the first
what's that?
value. What am I
F of x sub 0 plus h minus f of x sub 0.
subtracting from that?
And that's where that comes from. Okay.
Taking that distance, getting really close to 0. F of 1 plus h. What do you do with it?
And then he just finds the limit.
That. Turn it into a polynomial.
Okay, then he plugs f of 1 plus h into x sub 0 plus h, I'm guessing.
It's like one.
Wait.
Thing for you, right? Whatever I have in there, that's what you're.
Oh wait, y equals x squared. Okay. 1 squared plus h.
Plugging in. You don't do f of
Wait,
1.
no, it's not. Be 1 plus h squared.
The 1.
Okay.
Instead of f of.
We're good then.
Try at Did you all get 1? Is 3 over
Jeez,
what?
5 days to
I'll
get everything.
certain. All right, so let's continue this problem. We're talking about how to find tangents to curves at certain points, which in and of itself is a very interesting question. Specifically here, we're trying to find the tangent line to this curve at that specific point. And I've walked you through this already. What we're trying to do is fill out the difference quotient, which you guys are familiar with, and then take a limit as h approaches 0. In other words, letting one point get really, 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 really close to this point. Therefore, we have a tangent line to that curve at that point. So we're almost there. We have
Well, f of 3 plus h is 3 over 3 plus h, and then minus 3 over 3 over h. So 3 over 3 plus h minus 1 over h. 3 over 3 plus 1 over h. No, I can't do that. Times 1. Right, 3 times 1 over h. Wait, 1 plus h. That's still not right. 3 plus h minus 1. That doesn't change anything though.
we have our f of 3 plus h, we have our f of 3, and we're trying to find out, as h approaches 0, what this thing's going to be. That's what we dealt with last time. You remember inventing that last time, I hope, yes? Mm-hmm. Okay. So
that being a whole. If you plug 0 into this, it's 3 plus 0, so it's 1 minus 1. So I should be able to factor this out then.
we already have this part. We already have this part. Let's make our substitution, and then let's see what we can do with it. So if we have this, we'll have our limit as h approaches 0. Notice you have to keep writing your limit until your limit is gone. It's a must. Instead of f of 3 plus h, please tell me quickly, what am I going to have instead of f of 3 plus h? Okay. Are you okay on the 3 over 3 plus h? Yes, now you see where this is coming from? So instead of f of 3 plus h, I have, well, what that equals, 3 over 3 plus h. Then am I going to have a plus or minus? What do you think? Yeah, the formula says minus. Minus how much?
1.
Yeah, f of 3 is 1. All over what, folks? And don't forget that h. So we've just made a little substitution. We have 3 over 3 plus h for f of 3 plus h. Cool. Minus, minus. F of 3, well, that is our 1. So here's our limit as h goes to 0. Raise your hand if you feel all right with that so far. Good, all right. Now, quick question. Can I cross out the 3's?
No.
You know, I see a lot of people love to do that, right? You're going fast, like, oh, the 3's are the same. I get to cross them out. Yay. No, not so much. We can't cross them out because that's a term, right? That's not a factor. We cannot simplify that in any way, shape, or form. So how in the world are we supposed to get this h crossed out? That's our ultimate goal, because right now if we plug in h, we're going to get 0 over 0. Do you see it? That's going to happen all the time if you let h go to 0, because what this is the slope between 2 points. If you let h go to 0, well, you only have 1 point. If you let it equal 0, we're letting it approach 0. So we are going to have 2 points, but we need to find a way to manipulate this so we can cross out our h's so we don't have an issue with this. Any ideas? What now?
Common denominator.
Common denominator would be great, because right now I have a complex fraction.
Oh, true. Oh, look at that. It's a third. What was the point of... That was the difference quotient. Oh wait, we're not done yet. We gotta find the equation of the line. So this would be the slope then. The point 3, 1, y minus 1 equals a third x minus 3, x over 3 minus 1 equals y minus 1, add 1, it cancels out, y equals x over 3. It's the opposite, reciprocal, or just reciprocal.
I have a fraction over, well, a fraction. I need to make it one fraction of one fraction, that way I can still work with it. So what's our LCD, our common denominator, going to be? Yeah, when you only have one denominator, it's that. So instead of 1, notice you're still writing limit. I have 3 over 3 plus h minus, instead of having 1, would you be okay if I put 3 plus h over 3 plus h? Is that the same thing? Sure, yeah, it may as well. One becomes that. That is still 1. I'm just writing it special so I have a common denominator. Well, if we continue, well, let's see what happens. We've got a limit still. H is still going to 0. On the numerator, oh, let's check it out. On the main numerator, I know that I have a common denominator of 3 plus h. Notice when you add or subtract fractions, you do not change the denominator. On the numerator, what am I going to have?
H.
Oh, wrong.
What? No, bro, he's capping.
Say it again. Why?
Crap, he's not. Bruh. Okay, it can still work. So -1. -1/3. Plus 2. Okay.
Minus. Is that minus important? It's not really important, right? Right? Or yes? No. It's not like we're talking about slope or anything, right? Oh, wait. Huh. That's exactly what we're talking about. So if you have your sign wrong, your line goes from this to this, or this to this. Is that a big difference? Big difference. Freaking huge difference, right? No, we can't do that. So get your signs right. What's actually happening here is you have a parentheses around that. So what happens with any rational expression? And this says you have 3 minus 3 minus h. Minus h. Yes, no? Okay. All over h. That minus is important. So we'll have a limit. It's still a limit. H is going to 0. We have negative h over 3 plus h all over h. Okay. What now? What do you want to do now? Okay. Do we have complex fractions? Sure. We have 1 fraction over 1 fraction. Change that maybe into a fraction. Make it h over 1. You can do that, right? Then what you'll see is I have 1 fraction divided by another fraction. How you divide fractions is you reciprocate the second fraction and multiply. Do you see it? You have 1 fraction divided by 1 fraction. You reciprocate and then multiply. So that'll be negative h over 3 plus h times, I'm going to do this all at one step. I'm going to reciprocate and multiply times 1 over h. Times 1 over h. Are you okay on where the 1 over h is coming from? Are you sure? So I'm reciprocating and multiplying. What happens here? Yeah, I don't want to distribute that h, right? Because right now we have parentheses. You were taught in your whatever class you learned this. Extend that line, cross out those h's if you can, because they're now factors. What do I get on the numerator? -1. That negative, oh, that's important. -1, so this is the limit. This is the last time we'll write the limit for this problem. -1 over 3 plus h. Would you raise your hand if you can make it down that far? Feel okay with this? Good deal, that's great. Now, wait a minute, h is on the denominator. Can I plug in 0 and be okay?
Yes.
Yeah.
Yes, because I'm adding 3 to it, that's fine. If I evaluate, this is where you stop writing the limit. You say, okay, well, what this does, this equals -1 over 3 plus h. Oh, sorry, 3 plus 0. Because now we can let h go to 0. Now that we've eliminated that problem, that's all right. We can now evaluate that limit. We know it's going to be continuous. There's no problems. There's no holes or asymptotes at this point. What's our answer?
-1.
What would you have gotten if you had forgotten to do this negative here? Positive 1/3. Is your tangent line going to be correct? No. No, you would have an inappropriate tangent line. Okay, well, that's all well and good. Are we done now? This is kind of cool, though. What have you found? What is this thing here? Always have that in your mind, what you're doing. You're finding slope. This is the slope. This is the slope of that curve. This is the slope of that curve at that specific point. Do you follow me? Well, that's convenient, and it's not coincidental, but it's convenient because now we have the slope of this curve at that point. We now have a point and a slope, right? What do you need to make the equation of a line? You need a point and slope. So we have that now. I even gave you nice numbers. What a nice guy I am. Look at that. That's pretty cool. Are you okay on where the 1, the 3, and the negative 1/3 are coming from?
So it comes up positive 3? Oh, no, I already did that. It's +1.
We're taking the point that I've given you, we're taking the slope that you have found, and we're now making the equation of the line that goes through that point with that slope. Not sure if you're right with that one. Okay. So we have our -1, that's -1. We have our negative 1/3, that's your slope. We have our -3, that's the 3. If we distribute, we'll get negative 1/3 x, and then what? Plus? Plus 1. Very good. We're almost done. If we add 1 to it, y equals negative 1/3 x plus 2. Very cool idea. This line will intersect that curve at one spot. And it's going to do it at that point. So that is the tangent line to that curve at that point. It's kind of a cool thing. If you want to just talk about the slope of that curve at that point, well, that's the slope of the curve at that point. If you want to graph a line, that's the line. It's kind of neat. How many people feel okay with this so far? Now, the next question is, if I change points, does my slope change? Does my equation change? Yeah, they're all going to be different. Well, that's going to be annoying, because if I ask the next question, okay, find the tangent line to the point, let's see, 9 1/3. Then I ask, how about 2 3/2? Then I ask some more. You'd have to do this over and over and over and over again to find it for any point, right? Maybe we can be a little bit smarter and do it once and for all. Perhaps we could find the equation for the slope and then just plug in the x values. Would you like to see a way to do that? Yeah. So in other words, maybe I don't want to deal with a specific point. I want to say I want to find the slope of this function at any point. That's what I'm going to show you how to do now. So let's find the slope of the tangent lines. Forgot my L. Find the slope of the tangent lines. That just means the slope of the curve. to y equals the square root of x. At any point. At any point. Well, let's go through it. You know that ultimately what we want to do is fill out this equation. We know that slope equals the limit as h goes to 0 f of x of 0 plus h minus f of x of 0 all over h. You with me? Now x of 0 stands for a specific point, does it not? If we erase that f of x of 0, we're going to find it for any point x. You can use x of 0 if you want to. I think the book uses that as well, but you don't necessarily have to. It would be in general, for any general point. So, well, let's see. Can you tell me then, let's figure these things out just like we did before. Can you figure out what f of x is and what f of x plus h is? Let's try to fill this out. Then we'll make a small substitution to there, just like we did right here. And then we should be able to solve this thing out, provided we can eliminate the h. Let's try that together. So everyone, let's look up here at the board. What is our f of x?
Eliminate the h. How?
X. What's that do for us? So what was it? Square root of x. Very good. Yeah, that's because it says y equals square root of x. That is our function. So f of x is square root of x. So far, so good? Now, how about f of x plus h? F of x plus h. Is it f of x plus h? Like that. Is it f of x plus h, or is it f of x plus h? So what that says to you is x plus h, you cannot separate. Right now, what I've done is I've separated the x and the h. Do you see that? This is not the square root, this is not f of x plus h. This is f of x plus h. How do I find, let's compare it. So this is wrong. Leave that on your paper, just scratch that out. That is not the correct thing. What is the correct thing? If I want to input all of x plus h into my variable f of x. This is a composition, folks. You got to know how to do compositions. That's why we spent some time on it earlier. It's not square root of x plus h. It's what? Not just x plus h. That we ignoring the square root of
x plus h.
It's the square root, sure. And it says, take this whole thing, put it into the variable. Take the whole thing, put it into the variable. It's square root of x plus h. Notice the slight difference. It doesn't look that different, right? But the square root stops here and it doesn't stop there. this is the square root of x plus h. How many people see the difference there and feel okay with it? Is it important to have that difference? Yeah, it really is. Okay, are we ready? Can we make the transition? Yeah, we got it. We got everything we need. We got f of x plus h. Got it. We have f of x. Got it. H doesn't change. On your own, why don't you plug that in? Make the substitution. See what you get. I'll do it on the board at the same time. I always like to put this little tail on my square root to show me where my square root stops. That way I know it's after the h. I would hate for you to keep doing your steps, right? And this happens. First step, second step, third step, fourth. Oh, now all of a sudden it's gone, right? That would suck. Or it'd get longer and longer and longer, and then it's covering the whole thing. Don't do that. Just make sure you know where your square root starts, stops, and what it includes. So f of x plus h, great. Then we have a minus sign, and we have f of x. F of x was square root of x. All over h. Right, you got that in your paper. All right, good deal. Now, oh my gosh, how do we solve it? Just give up. Let's just go home. This is pointless anyway, right? Now, if you plug in 0, you're going to get 0 over 0. You see it? 0, 0. That's a problem. So your whole goal here is to get rid of the h here. That's your goal. Now, there's of course ways to do it. In fact, I've shown you a problem quite similar to this, with involving those square roots. Do you remember?
Multiplied by the conjugate.
Do you remember what the conjugate is?
Okay. Always forget you can do that. What would this be? Doesn't matter, it cancels out actually. It's left with an h. What am I doing? Alright, so that's good.
Whenever you have square roots like being subtracted, or square roots in any case, you're taking a limit, one great idea, change the sign, multiply by the conjugate. That's always a good idea to do. Do that right now. Multiply, wait, is it just the numerator or both the numerator and denominator? Both. Multiply by the conjugate right now, okay? You're going to need to distribute the numerator, but do not distribute the denominator. You're trying to get rid of the h on the denominator. If you distribute it, you'll have to refactor it anyway. Hey, does this sign change? I know this one does. Does this sign change as well?
No.
No, okay, good. remember we have parentheses here, which means you're
I'm gonna end it there. Finish it tomorrow.
going to have to just